Hello everyone and welcome to this week's Secrets of Flow. I'm Alexei Zheglov speaking live from my place in foggy Toronto, Canada. It's 12 o'clock noon here right now, Tuesday, December 10th. This is your time and place for insights and actionable advice on improving the world of work. I titled today's episode, How Long Will It Take? How long will it really take? So, today we'll talk about time. You start something, you do it, you finish it, you deliver it to customer, how long this will take. And of course, there will be plenty of advice and insights, I hope, for people in different roles. Such as, let's say, if you manage projects, if you're on PMO, if you are a delivery manager, or maybe you are kind of in a higher position like a chief technology officer and several such people work for you. Maybe you are a leader of a team, and there will be something for you today that will hopefully help you answer this question in your actual work situations. Now, as far as how long this episode will take, that's an easy question. Up to 55 minutes. So far, I succeeded 5 out of 6 times at this. I do intend to keep this hour a little bit shorter, so that you have a few minutes for changeover, because I understand people listen live sometimes during, let's say, their break in the schedule, such as lunch. For some people in this time zone, for other people maybe a break in the meetings. Some people watch it as a recording, finding, again, some time in their schedule, fitting it somehow. So I plan to keep it just a bit short and have a clear time frame for this. However, today we'll be talking about your work, which is not nearly as predictable. There is a lot more uncertainty in its duration, and it's particularly difficult to manage because, and once again, I'm going to repeat this to set the context, we're talking about modern, intellectual, creative work, which is largely invisible. It's just thoughts in people's heads, and it's very difficult to see how it's progressing. And of course, it's difficult to kind of measure this progress and make promises and predictions. So I'm going to start with one really big, important piece of advice on this. And maybe 10 years ago, I didn't realize I'd be saying this today, but this is really number one on my mind when I'm faced with the question, how long will it take? There are basically two different kinds of deliverables. Two very broad classes of things we can do, finish, and ship to our customers. And these two broad classes require two very different sets of approaches. And it's important, therefore, to figure out which of these two classes we are right now, what type of deliverable we are talking about, and then apply the appropriate reasoning, techniques, and data. So I'm going to show you what these two things are in a minute. So the first kind is basically what I call batches or projects, and the second kind is what I call a single work item. But let's start with bigger things, batches of units of work. So let's say this is a very simple visual management board. It's basically it's kind of a generic sketch. Some work is completed, some work is current, some work is still remaining to do. So we can, let's say, start working on some of these things, and we can visualize it, let's say, using work item cards. Then some work is completed, and we start more work, and the process continues. You may have, let's say, multiple teams working on this. Yes, so there's not one person doing all this. So, and sometimes, let's say, these teams may be organized and dedicated in such a way that they actually work on just one of these things at a time, and when they finish something, well, they pull the next thing, like this. And, that some actual organizations work somewhat differently, and maybe some teams handle more than one thing at a time, and maybe they are in different stages of progress, like this. And some teams sometimes add in more work. So the amount of concurrent work can be really anything. It depends on how you really manage it. But eventually, the work progresses towards completion, and basically the question we're asking when we say, how long will it take, is when this entire batch will be in a completed stage. All right, you get the idea. I'm just going to skip moving individual cards. You get the idea. When will this whole thing be done? And it comprises multiple, sometimes tens, potentially hundreds of work items that your customers expect you to do. So this is a pretty common situation. So you can think of, let's say, project work working like this. You can break down a project into a bunch of things and then ask, when will this number of things be done? However, this can also happen very much in a product development environment where you basically have continuous delivery, one work item at a time. That can happen too. For example, your technology team may be working like this, completing one small feature at a time. Something is deployed almost daily via continuous delivery pipeline. However, your marketing department is asking, okay, when will this sort of set of functionality be finally deployed and ready for customers to use so that we can start some kind of promotion? Or maybe your sales are asking when you will reach that point. Because, maybe that's enough functionality to establish a premium pricing tier by subscription. So, sometimes the work can be completely continuous from one point of view, but from a different point of view, for some kind of synchronization purpose, we still want to know when a batch of work items of a certain size, in terms of number of work items, or specific work items, will be done. So again, the question, when will it be done, is asked about a collection of work items. So please don't hate batches. They're not just for large scale projects. They have their use in pretty much continuous feedback driven product development environment as well. And so when the question, how long will it take, is asked in this sort of situation, we have to realize the biggest uncertainty here is how many work items are we dealing with? Does this project consist of 20 work items, 100 work items, 500 work items? That will largely, at what rate are those being completed? Those are largely the determining factors on how long will it take. And whatever uncertainty exists around this has something to do with our assumptions about the throughput or the rate of work completion in terms of, let's say, number of work items per week or per month or whatever unit of time fits you. But it also arises from uncertainty about how many work items total. And maybe we think their number is 100, but how do we know that? And can't that number somehow magically rise to, let's say, 150 or 200 or 300, known as scope creep sometimes? But sometimes, even without scope creep, that number finds a way to magically increase. And of course, some uncertainty will come from that. However, let's talk about another type of work, and I'm just going to move to a different screen where I have a different type of work displayed. And so I'm sorry, just gonna take me a minute to scroll to this part. Okay, here it is. All right, so that new kind is a single work item. So here it is in the ready state, and there are, well, at the opposite end of this simple sketch of a visual board, there is a completed state. This is when the work item is done after some time, how long it takes. And in the middle, there are several activities. I intentionally just didn't label them specifically, so as not to anchor your expectations to, okay, well, this process is for this industry or for that industry, In any industry, you are going to have several activities. And if, well, some of you regular watchers and listeners of this show, thank you very much for doing so. Remember a few episodes ago, we talked about mapping the process and finding these activities of the process. What we also found there is that actually a good process map reveals to us a number of collaboration patterns and also sources of delay that can happen to a work item in this process. And so we already see there is a number of work items in progress here in various activities, and we can see that some of them are blocked for different reasons. Some of them aren't, like for example, there's some kind of blocker here. It may affect every work item, maybe not every work item. There's some kind of external dependency here. Maybe an outsourcing vendor is doing part of the work. Here there's a chance a work item will get blocked, but for a different reason than in the first activity. In the fourth activity seems to be multiple items are blocked, and potentially our item will get blocked as well. And it will eventually be transferred to the completed column as it's done. So how long will it take? The answer to this question, and the good answer to this question, largely depends on knowing what sorts of risks of delay exist in your process and its various activities. So probabilities to incur these delays, and if you incurred the probability, how big is the impact in terms of, let's say, the number of days this will cost you. So single work items versus batches of work items, we need to look at the problem differently. The amount of time and the uncertainty about the amount of time it will take will depend on very different factors. So today, however, I will largely talk about the single work item situation, and that's for a reason, and that reason will become apparent towards the end. So let's have a look at, let's say, time and process metric. And I'm gonna show you an example. It came from a particular team level kind of manager in one of Toronto companies a number of years ago. And this is kind of what it looks like. I'm gonna bring it on the screen shortly. So basically what the manager has done here is just simply noted start and finish of every work item, subtract the start date from the finish date. That gives you a number of days in between. And after doing this for a number of things completed by his team, he was able to create this bar chart. What we see here on the horizontal axis, that's the number of times it took to complete the work item, some kind of feature for the website of the e-commerce company where this team worked. And of course, on the vertical axis, the height of each bar, that's how many work items took exactly that many days. So we can see there's one particular item that took only 1 day, then 4 items took 4 days, 4 items took 5 days, and so on and so forth. Turns out there was one mysterious item that took 67 days. So the average number of days in this chart is 12. So it's right around here, just a little bit maybe past the peak of this distribution. So this is basically a pretty unpredictable and high variability process, and you can probably feel this unpredictability very intuitively. Quite a few customers are going to see pretty good, fast results from this process at the range of 5 to 10 days, right here. However, that's going to set customer expectations that will be frustrated quite often, because you can see also see the range. Let's just actually, let me take a pen and highlight it. So let's say customer expectations, they're largely set here in this range. However, this will not always be satisfied, and there is a pretty significant probability that will end up somewhere here in this red range, let's say from about 10 to 20 days. And sometimes customer dissatisfaction will be quite high with work items that occasionally take like the amount of days completely out of range. So so it's going to be pretty difficult to keep customers happy with a process like this, and something has to be done. And before this has to be done, we need to, let's just basically analyze what's going on here. And this is something that the manager did, and this is a pretty good story, and that's why I chose this as an example. It's also quite simple. There's not a lot of data and not a lot of details to understand, but it actually captures very well what the sources of unpredictability and sources affecting the duration of time are. So one question that often arises in this sort of situation is, all right, we have such a wide range of variation, there might be different types of work involved. And this is a good question, and now I have to disappoint you, this is not the case. This is a single work item type data. Again, about 3 weeks ago, we talked about mapping the process, and one bit of advice I gave there was that in a realistic process, there are several different types of deliverables, several different types of what, and they may potentially follow different process. So before actually mapping the process and trying to improve it, try to identify and name those different types of what, right? And what I often see when people first gather time metrics from their process, it's usually a mix of different types of work. And you know, if you actually see that the data set you're looking at mixes multiple types of work, well, filter it by the type of work right away. And the next time, do it right away so that when we're looking at a bar chart like this, it's already filtered. So we're only talking about one type of work here. And what's interesting is that there is sometimes, like for people who haven't done this practically, they have a theory, and it's usually proven wrong by reality, is that okay, we have some little defect fixes that take 3 to 5 days or 1 to 5 days. We have some kind of bigger new functionality that takes maybe between 1 to 3 weeks, and we have some other things that take 1 to 3 months. And so if we, let's say we have a combined data set of time and process, we should clearly see these three clusters. And, from seeing these clusters in the data, we will learn that, we have three different types of work. Well, a much easier way to learn that you have three types of work is actually when you map your process. And actually, before you draw the diagram of a process, you ask, okay, what types of work are present, right? And that's when you know it. So pretty much everyone, let's say, who is in software business knows there are new features and there are bugs, right? And these are two different types of work. So you shouldn't be looking at some kind of metrics charts and look for patterns in them in order to find out that you have features and bugs. You should know that already, right? So, however, even if you once encountered a data set of time and process that isn't broken down by type of work, please next time make sure it is broken down. And the surprising finding from this is that the pretty wide range of variation doesn't seem to go away. So now we are within one work item type, but there's still pretty wide, breathtaking range of possibilities from 1 to 67 days here, an average 12. So what's going on here? And now I'm going to show you what this particular manager did with the data. And it's pretty simple. Breaking down the data into two sets just by one factor. Let's change back to this screen. This is what it shows us. All right, so at the top, the blue work items, and that's about 70% of all work of this type delivered by the team. You can see the distribution is actually very compact. So and the average here is 9 days. 9 days, and this is roughly where the average is. It's right around here. This is the average. And also the maximum number observed is only 23. And actually the majority of work is completed within, let's say, 9, 10 days. Actually a good chunk of it within like only 4 or 5 days. And the worst case isn't all that bad. However, the second subset of work items is actually showing not such a happy picture. The average here is about 20 days, so it's about twice as much. Twice as much is useful information. And even the best case is already at least a week. Right, so you're not seeing, let's say, among these orange work items, any low numbers like 1, 4, or 5 days to delivery, and it's actually with the orange work items that this big outlier of 67 days occurred. So what is really happening here? Remember, this is still one type of work. Well, it turns out the answer was very simple. The orange items were affected by dependency. If you actually trace their history, it turns out blue work items were largely done within this team. And the orange item were blocked because they required help from an expert in the database architecture group of this company. And this external dependency and the time spent in blocked state added quite a bit of time to how long it will take. So we can roughly quantify the impact of this dependency. The difference is 11 days on average. So if we incur the dependency, it's 20 days versus 9 days. And the probability to hit this dependency, well, let's say it's roughly 30%. In this case, it was 7 out of 26. Right, so I mean, we don't have a very precise number of this, but it's roughly in this ballpark. It's not negligible. It's not like 10 or 5% or 1%. It's like a quarter, maybe a third of work items are affected by this dependency. However, it's clearly not half or the majority of the work items. So this is what's happening here. And now the question is, can we do something about it? So clearly this dependency is a very important source of variability. Well, something can be done. So from, let's say, the point of view of this particular team manager, there are several available strategies. Well, first of all, we can anticipate the dependency. Right? So when we start work on this work item, instead of just working halfway into the process and then discovering, okay, well, this item is now blocked. Oh, why is it blocked? Oh, because we need this and this, and we need to reach out outside our team, and we have to get into somebody's queue or backlog and wait until they do their part. How long will that take? Well, we could be more proactive and uncover this dependency sooner rather than later. Maybe it even becomes possible before we even start the work. Let's say a particular new feature, we can basically anticipate that it has some kind of performance hit on the database, and we're going to need help from an expert in order to optimize the queries, and do some other tricks database architects do to make sure that our core functionality still works without, let's say, a hit to the database performance. And we can potentially schedule time with our database expert ahead of time, so we shorten the impact of this dependency. We can also increase the level of skills within our team. And then fewer items, a smaller percentage, let's say maybe not 30%, but maybe just 10%, will be impacted by this dependency. Something can be done, let's say, from the leader of this database architecture group as well. They can also anticipate the demand coming to them, and it comes from this team and also a dozen of other product teams in this company that develop various products and applications, and all of them from time to time need help of an expert. And that's why they come to this database architecture group. They can anticipate the demand. They can potentially figure out some kind of strategy to make sure that everyone gets the amount of help they need and no one has to wait for too long. Actually, if we look back at these charts, if we look again at the situation, actually most of the time this dependency wasn't all that bad. It's just basically like, okay, well, 7 days is the worst case. However, in only maybe a week longer, most of the requests are handled. And within 2 weeks, virtually all of them were handled, save for that outlier. So the thing is, and again, going back to last week's episode about utilization and responsiveness and 20% time, when product teams reach to shared services for help, if that shared service is overburdened, if it's in a high queue state, we can expect less responsiveness. So sometimes, we're lucky and we hit it in a relatively low queue state, and then, the response is faster. Sometimes the queue is longer and the response is a bit slower. And sometimes we find it in a kind of state of chaos, and then it can take really a lot longer. So some kind of policy, let's say round robin, but it doesn't have to be a perfect round robin because different teams have different needs, but at least ensuring that we don't leave any of the team without some kind of help or response for a very long time, and we do get something to everybody. That could be an approach you take if you manage a shared services team such as this database architecture team. So those are some of the strategies. However, now I'd like to, let's say, take kind of a more strategic and anticipatory kind of point of view. And sometimes, let's say, when I speak about something like this or give advice on situations like this, and when my colleagues, let's say from Squirrel North, do this, as Fernando Cuenca recently did, and he encountered the following question: how can we uncover such insights, let's say, from our work management tools? Right? So clearly I just gave you an example how a particular team manager found a very interesting insight. There is one factor, and it's really like a binary factor. Is there a dependency or not for this particular work item? It just basically makes a huge difference in terms of how long it will take. And that particular one factor is basically bigger than any other factor affecting variation in this process. So it's like, if this factor is present, then the time more than doubles. And in the worst case, it more than doubles, right? So 67 days versus, let's say, 9 days on average. So it's almost an order of magnitude, right? And that's just one factor. How can we find this sort of insight? And folks, I would like to suggest a very simple approach here. And it's really not about metrics, not about numbers, and it's really knowing what business you're in. And even as a team level manager who may be like several pay grades below, let's say, people who make strategic choices in this business, you still need to know what business you're in. This particular company is in internet commerce business. So what does this mean? Well, they have millions of customers. For this company to, let's say, make $10 million, that will probably come from a $10 margin on purchases by 1 million customers, rather than, let's say, 10 huge customers, let's say buying a piece of equipment, $1 million each. So what this means as far as enterprise architecture of this company, database is going to be central. The database with millions of customer accounts and absolutely countless orders and transactions and billions of events, right? So that's a lot of data structured in some kind of complicated way. And clearly, one big concern is, can this thing function with, let's say, reasonable performance? Can it hold up when, let's say, all these customers do something concurrently on the system? Let's say on a Black Friday, can it function with tolerable latency? So let's say pages load quickly, transactions execute without too much delay, and so on and so forth. So performance and databases, effectively the bottleneck of this system, is going to be a concern. Now, why is it a performance bottleneck? Well, that's because of a chosen business model, right? So, I mean, if you're going to have millions of customers, you're going to have an awful lot of data, and database is going to be very important piece of technology for you. And it will be kind of a constraint of a lot of things. So you're going to need to employ people with very deep expertise in database technology in order for your business to succeed. And generalist product development teams, well, of course, a generalist software developer can have a decent amount of database skills, but it may be unrealistic to have a dozen product teams, each basically having an expert level of knowledge. And at some point, they will need a real expert with a lot of depth in database performance. So you can almost anticipate this dependency just by simply knowing what business you're in. And I'm just gonna go back to one of our previous diagrams of the process. Let's go back here. So let's say this yellow figure, this is basically this team doing the work, right? And remember how we mapped process maybe 3 episodes ago and identified the collaboration pattern for each dominant activity? Well, in this particular process, it's all pretty simple. The most salient feature of this process is the dependency on the database architecture group, and it exists basically because of what business we're in. So this yellow figure, now that stands for the team doing most of the work, and 70% of the time they don't need any external help, but 30% of the time they need to reach out and collaborate with an expert. So this little smaller red figure, and that's going to be the major source of delay in the process. So we know this pretty much by simply knowing what business we're in and what like the basic outline of the process looks like. And as soon as the leader of this team realized, okay, this is what I can expect, this is what our process looks like, okay, yeah, we're going to have this dependency. Okay, let's check. Oh, of course we have. Out of recent work items, this is how many were affected by it. Sure. Okay, let's find out how much it's costing us. Okay, well, 11 days on average and 50 plus in the worst case. So that's how we know these sorts of tricks and sources of unpredictability when it comes to work items. So I would like to now summarize some of the advice that we can give to various people. So first I'll start with, let's say, leaders of teams. So as I said, knowing what business you're in is very important. Understanding how that affects certain choices in your process. If you map your process, it's going to look in a certain way. Well, it looks in a certain way kind of because that makes sense, or it evolved under some pressures because of the business you're in. This database expert dependency in the example. And that's going to be a pretty important source of unpredictability, and the sooner you identify it, the better. You're going to need some good working relationship with that group outside your team that you sometimes depend on. So you need a good working interface, how you send them some work, how you ask them for help, how you set expectations, how you get some results back to them and incorporate them into the work that your team delivers. So maintaining this cross-team, potentially cross-department collaboration is important. So it's not just about what happens with your team, but where your team fits into the bigger picture, as I said before. Now let's take a look at this situation from the perspective of let's say in this example, the leader of the database architecture group, the manager of that shared service, what can they do practically? Well, it's very important for them, very important for you in this situation, to understand who your customers are, to know what these product teams are and who their leaders are, who will come to you for help in certain situations. And sometimes you may notice that one of these teams, one of the leaders is no longer requesting this service. And that could mean two things. Maybe they actually increase their level of skill to the point that they no longer need you as an expert. Okay, well, that's good. Now, the more likely scenario is that this is just a pent-up demand. And at some point, a wave of requests from that team is going to hit you. So if you haven't actually heard from one of your regular customers in a while, it may be a sign of pent-up demand, and perhaps it will make sense talking to them rather than, have kind of the false safety, pretending that one of the sources of your demand somehow disappeared. So from the point of view of, let's say, a senior manager, let's say a program manager, program uses, let's say, multiple product teams and multiple shared services with such dependencies. Maybe a chief technology officer runs multiple such programs. So again, an important bit of advice here is that a lot of performance of your program or the technology department you're managing is going to come from how well all these different types of teams interact and how these interactions create value, such as very good overall performance, despite database being like pretty difficult, and at the same time within the reasonable and predictable time, right? So this is not a matter of individual team performance as it's sometimes viewed. So anything you can do to improve collaboration across teams and making all such dependencies transparent, that's going to help all of them and all your organization. So that's pretty much it at 42-minute mark. What I wanted to say about how long it will take, as you can tell, like even considering a single work item type situation is not all that simple, but at the same time not all that complicated. But it does take quite a few minutes to properly deal with this situation and understand what's going on here and how we know these things and what we can practically do about them. So it takes time for me to say all these things. I would like to add kind of as a bonus towards the end of the show just a few more things about approaching the two broad classes of deliverables. Once again, it's these kind of projects or batches, but it's also kind of a single work item, which is right now on the right hand side. So kind of contrast the two. So one very important practical advice: if you don't have a mastery of what's on the right hand side of this picture yet, understanding how you deliver just one single work item and understanding sources of delay affecting how long it will take. It may be premature to get into the world of, let's say, forecasting deliveries in the projects and large batch work on the left. So, and the reason for this is, I'll try to make it simple. Let's say we're looking at a pretty wide range of variation for a single work item, and you saw it in this example. Average 9 days, best case 1 day, worst case, we actually don't know, but the worst observed is 67, right? The worst observed won't necessarily be the worst, right? So what does this mean? Let's say you start a 4-month project that comprises, let's say, dozens of these things. And let's say in the last week or two of the project, you start a work item and it takes 67 days. Basically, your project's total time had a 50% error, and it was due to just one work item, right? So when you have this kind of unpredictability of work item time and process, then it's very difficult to forecast time of project completion, just simply because of this factor. However, let's say if you reduced that range of variation, so it's now, let's say, not 1 in 67, but we've taken some tactics that basically is going to reduce this dependency and reduce its impact, and that's going to have a significant impact on, let's say, the worst case of time and process for single work items. Well, now kind of it's a happier situation because we're clearly going to avoid such excesses, right? So we can also kind of anticipate that, let's say, the longest work item is perhaps the one that hits this dependency, and we should basically anticipate it, and we shouldn't be scheduling it late in the process, right? So if we're conscious about this dependency or mindful about it, right? So we should be now we know it as a risk factor. We should be actually marking items potentially more exposed to this risk factor and starting them early in the project, right? So we can actually be in pretty good shape as far as forecasting the batch. However, then batches will offer, of course, us a different challenge, because we may think that we're going to need to deliver let's say 100 items to satisfy project requirements, but that number in reality, because again, the work is invisible, the work is just thoughts in people's heads, the work tends to emerge. We may uncover new work items as a consequence of simply completing the previous work items, just given even the same project requirements. But that delivery batch can very well grow from 100 to 150 or 200 when all is said and done. And how you control variability in terms of the number of work items in the batch, that's a harder problem. But you have to solve the simpler problem of single work item type variability first. So that's that's what I wanted to say about the precedence and how you deal with these two types of situations. So master single work item process first, then worry about forecasting batches. The second thing I wanted to say, maybe this is the last one on the subject matter, at the 49-minute mark. It should be said that actually in the last 20 years, a lot of database-related technologies appeared that are actually quite optimal for all sorts of situations. And so if you're looking at storing, let's say, such and such large number of customer accounts and order history and transactions and various other events, There are currently various database solutions out of the box, a lot of open source software you can potentially use that basically optimal for that type of problem. Actually, there's a variety of them optimal for every which type of problem. So some of the problems that we may be sending to our group of database experts may be effectively solved problems, and we can simply incorporate them into our work already and reduce the dependency, right? However, it's important to realize, now I'm going to get a bit philosophical, but only for a minute or two, that if this solution is already readily available, it is also available to your competitors. And you need some kind of edge over the competition. And so it means you will perhaps have to push technical complexity out a little bit in order to provide your customers the best possible experience. And as you try to provide them that best possible experience, your technology will get complicated in a way that isn't easy to solve with off-the-shelf solutions. And then once again, you're going to need an expert, right? And so the dependency, perhaps not on this group, but on a different group, and your database expert's skills will evolve as well, so maybe it will be the same group. But that sort of risk and that dependency will remain. Of course, on the flip side, there is a reward that you are providing your customers with great experience powered by this complicated technology, and you stay just a little bit ahead of your competitors. So that's the end of my philosophical rant. And finally, I just wanted to make a couple of announcements. So one is a community announcement, and it's about our next Kanban TO, which is happening next Monday, December 16th at 7 in the evening online, Toronto time. And it will be a case study from one of Toronto's high-tech companies, and the engineering manager in charge of observability and DevOps will share his story. And Fernando Cuenca, our Kanban expert, will facilitate this as well as some community discussion. And finally, I'm going to annotate this video with like timestamps every 2 to 3 minutes and post this on YouTube by about 3 or 4 p.m. this afternoon. So please watch out for that. The video will be a bit more watchable as opposed to just watching it from start to finish. Tomorrow I will announce the topic for the very last episode of this year. It will be a half episode, half length, so 28 minutes, next Tuesday, December 17th, and then I'll take a break for holidays for 3 weeks, and we'll restart in January, and then maintain the weekly cadence as we just did throughout November and December. And for people who prefer perhaps a textual version of these talks, that will start happening too in the coming weeks and ramp up in January. That's my plan. Thank you very much for watching, listening, finding time in your busy day. See you next Tuesday. Goodbye.